So today we discuss electric potential energy of a system of charge. Okay. So previous class we discussed about here the calculating field from the potential. Okay. Very easy concept. And now today we discuss the new concept. It's not a new concept. Okay. So electric potential energy. Electric potential energy energy of a system of charge of a system of charge. Actually, system of charge means that the system contains some charges actually. So first we choose the two charge system. Okay, choose two charge system. Two charge system. So here, if you want to calculate the energy, potential energy, so in two charge system, suppose this is a blank screen. Okay, suppose the system has zero charge. First assumption is that system has a zero charge, no charge. So first I bring a test charge from infinite to at that point here. Okay, suppose the point is Q1. Okay, and now the system contains one charge, and this charge is called source charge because this charge produces an electric field. Before that, the system exists, but there is no charge. Okay, means no charge means no field. Okay, so now system contains one charge, and that one charge create a electric field. Now we bring another charge, suppose Q2 charge, a positive Q2 charge, that is a positive Q1. Same concept at infinite to that point, and that gap is R. Okay, so that is a Q2 charge. So there is a work done. Okay, because this charge is positive and this charge also positive, so there is a repulsive force and work done against the repulsive force. Okay, if this charge is released from here, this is swept away from that Q1 because there is a repulsive force. So there is a like charge actually. That's a repulsive force. Now against that repulsive force, we need a work done. So that work done W bring Q2 charge, a test charge from infinite to that point. That is a potential difference. So from infinite to some point, 2 point. Okay, suppose not say the point, say point P. Point P. So final point potential energy. Final point means point P minus initial. Initial to final. So bring a Q2 charge, move initial at infinite to final at point P. And you know that potential energy at infinite, that is a 0. So W equal to get UP. Okay. And we know the potential at point P. Okay. Now we know that potential at point P and potential also independent of test charge, that is equal to Q1 by 4 pi epsilon naught times R. Okay, and if we both sides multiplied by test charge, suppose multiply Q2 charge, and we get work done or call energy, potential energy at point P. Okay, so we get a potential energy point P, that is equal to Q1 Q2 by 4 pi epsilon naught R. These and these equal to in two charge system. So one charge be the source charge, another charge now behave as a test charge. Okay. So potential energy of the system of charged particles, sum of potential energies of every pair of particle in the system. Just be added. Okay. Now, if the system contain three charge, or system contain there is a two charge, we get another charge. What will happen? Now consider the three charge system. The three charge system. Okay. So there is a blank screen, means a blank. Okay. So this system exists, but there is no charge. If no charge means no electric field. Now bring a Q1 charge, positive charge, from infinite to that point. Okay, at Q1 infinite to at point 1. And that now suppose say that is the origin O to that is R1, position vector is R1. Okay, if a Q1 brings infinite to that point, because there is no electric field previously, because no electric field, so no work has to be done. Work done with a 0. That's why what is the work done actually? The work done concept creates, you can see that if there is either a attractive force or repulsive force, against that force we create a work done. We do some work actually. But before that is not a repulsive force or not attractive force. That is only Q1 charge. So there is no force exists. Okay, not a Coulomb force. There's a two charge must be needed. When Q1 is placed from infinite to that point, now that Q1 produces electric field. Before that, the system exists but no charge, means no electric field. Okay. And when Q1 from here, then no work done. Okay. The first case, when Q1 brings infinite to at point P, so work done with a 0, because that is no repulsive force or no attractive force. So that is no work done must be needed here, must be needed. Now, another important. Now bring another charge. Suppose the Q2 charge here. These Q2 charge bring infinite to that point. From Q2 charge infinite to point 2. When Q2 charge bring infinite to point 2, there is this system also contain one charge, Q1 charge. Now Q1 charge behave as a source charge and produce electric field. If Q1 produce electric field, so that will obviously work done present here, because that's a repulsive force. If both charges are like charges. So position of Q2, say that is a R2. Okay. When Q2 brings infinite to that point, so here the potential obviously present at Q2. So when Q2 brings infinite to at point 2, here the point 1, point 2. Okay. So potential V2, that is W over Q2. So V2 equal W over Q2. W be the work done in external force, actually bring the charge infinite to that point. Otherwise, this charge swept away. Okay. So that's a work done. Now that work done, the test charge bring Q2 charge bring infinite to at U at point 2 by Q2 and U infinite be the 0. So potential V2 times Q2, we get okay, there is the error. Sorry. Actually, that is a U2. Sorry. That actually U2 infinite to 2. Sorry. That is 0. So that is equal to U2. Okay. Infinite at initial to initial point, that is the final point. And that is a work done equal to change in potential energy. So final energy minus initial energy. So that is Q2 V2, that is equal to U2. Now, what is the value of U2? That is equal to V2. V2, the potential is independent of test charge. that is equal to Q2 times V2, that is equal to Q1 by 4 pi epsilon naught, gap between these two, that is called R12, say, that is equal to Q1 Q2 by 4 pi epsilon naught R12. That's important. Okay. Now we take another charge, Q3, three charge system. Q3, suppose take Q3 here, that is a Q3 test charge. Okay, from infinite to that point. When Q3 test charge or another Q3 charge bring infinite to that point, 3 point. Okay, the point is 3. Okay, and position is R3. Okay, when Q3 here, so Q3 experience, okay, so potential and energy due to Q1 and Q2. So Q1 produces electric field. If Q1 produces electric field, so here is a potential due to Q1 and potential due to Q2 obviously. So here is two work done. Okay, two work done is needed when Q3 bring infinite to that point 3. So first work done need to repulsive force due to Q1, another due to need work done due to repulsive force of Q2. Okay. So here we see that for due to Q1. Okay. So point 3 and infinite to 3. Okay, final minus initial, that is equal to energy change in potential energy, that is equal to obviously work done. The work done against the repulsive force, because these two charges are positive like charges, so there is a repulsive force. So against that repulsive force we need to work done, that is equal to the charge Q3 charge, we have as a suppose a test charge. Okay, so we divide, if I divide suppose U3, we know that potential infinite is 0. Okay, divided by Q3, and we get potential at 3 V3 due to Q1, and that is equal to, okay, equal to U3, and suppose due to Q1, here we calculate the U3 due to Q1, we get Q3 times V3 due to Q1, and potential 3 due to Q1, so Q1 now behave as a source charge. So we get that is equal to Q3 Q1 over 4 pi epsilon naught R, separation between these two, that is R13. Okay, okay, that's due to Q1, and another is important due to Q2 obviously. Same case, same condition, U3 from infinite to 3 point work done, that is for Q2. So here U3, similarly that is obviously Q3, that is charge divided by potential at 3 due to Q2. Q2 behave as an source charge. So U3 due to Q1, Q2, that is equal to V3 Q2 times Q3, here cross multiplied. So we get V3, that is a potential, we know that is independent of texture, so that is Q3 Q2 over 4 pi epsilon naught, and that distance between these two. That gap is R, suppose 2, 3. 2, 3. And Q3, that is charge, need actually work done from infinite to that point 3. So here the work done here due to work done need due to here Q1, that is due to Q2. Against that repulsive force due to Q2. Okay. Now, so energy U3 depending on Q1 and Q2. So potential at Q3, V3 of Q1, Q3 test charge due to Q2. Suppose now we added these two vectorically. Suppose Q3, V3 of Q1, Q3, V3 of Q2. Now added these two. So Q1, Q3 over 4 pi epsilon naught R13 plus Q2, Q3 over 4 pi epsilon naught R23. Okay. So here we get potential energy on charge 3. Here the potential energy on charge 2. Okay, and here we get a potential energy at a zero potential. Okay, U1 that is equal to 0. Why U1 0? Because that is when over Q1 from infinity to that point, when that system has zero charge. If system has zero charge, means no electric field, it means no electric field, means no potential. So no work done needed to from bring charge Q1 from infinite to that one point. Okay, so work done actually needed for there is a attractive force, otherwise repulsive force. Okay, so if side like that, if I charge 2 when bring infinite to that point, so Q1 not now present that. So now we work done because otherwise that Q2 swept away to the infinite. Okay, so against that repulsive force, that positive like charge they repel each other. So against that Coulombic or electrostatic force, that electrostatic repulsive force need to work done. That is work done is U2. And in Q3, U3, so there is a 2 charge. So create a electric field due to Q1 and similarly Q2 to 2 potential, 2 charge. Okay. Now the total is important. The total charge U total that is equal to U1 plus U2 plus U3. U1 with a 0, U2 we get U2 that is Q1 Q2 by 4 pi epsilon naught R12. Q1 Q2 4 pi epsilon naught R12 plus here U3 that is Q1 Q3 over 4 pi epsilon naught R13 Q2 Q3 4 pi epsilon naught R23. That's the total energy of that system. Now box that. Clear? How to calculate the 3 charge system? Now we discuss the potential energy of an external field. Now calculate potential energy. Calculate potential energy of an external field. Of an external field. Okay. So difference between previous this point actually the potential of 3 charge system, equipotential electric potential energy of a system of charge, same system of charge, but calculate potential of a external field. Suppose there is a blank screen, the system, previously the system has no electric field, previous topic, now that system has placed on external electric field. So system placed on external electric field, that is an external electric field, is an external electric field. This field is external electric field E. Suppose we bring a charge, suppose charge Q1 at point 1, bring the charge from infinite to point 1, and the position is from origin. So that position is now R1. Okay. So need a work done. In previous topic, there is a no electric field, means no work done must be needed. But here work done is needed because there is a electric field. Because there is a electric field. So that's why potential at point 1, that is equal to W over charge Q1. So W equal to Q1 times V1. Okay. So actually the W came from the charge, the Q1 test charge or a charge brings infinite to point 1. So potential energy difference, that is equal to delta U, that is a final one minus initial. Initial is the infinite. So you know that initial is the potential 0. So U1 that is equal to W times Q1 V1. Okay, so there is a external electric field corresponding to the external potential. Okay, at the point they had been at point any point. Okay, point 1. So here that energy, there needs some energy here associated with this concept. U1 that is equal to Q test charge, either being a positive or negative, doesn't matter, times potential at that point. If Q1 test charge, potential at V1, energy at U1. That is a potential energy of an external field. Okay, that is an external field due to as an energy. If electric field is not here, if electric field be the 0, if U equal to 0, so U equal to 0, not here, because sorry, there's no work done actually in it. Okay, no need to work done from bring charge infinite to that point. Okay, clear? If you wish to write some note, then pause the video and write down the note. Otherwise, if you want to write your own words, that's very good, and if that's the very important. So that's 2 points. If you want to write the note, so pause the video. Otherwise, write down in your own words. Okay. So for some student, we write some note. Notice like that if I describe that point, that's description I write here. Okay. The external electric field, the external electric field, otherwise you skip that part. Okay. Electric field E corresponding external potential external potential. If electric field here, so that is potential, obviously here external potential V may vary point to point. Point to point. If suppose potential at point 1, here the potential at point 2, that is potential, that is V2, because that is R be the difference. Okay, the difference is R. Okay, point to point by derived V1. So work done needed. Okay, bring a test charge, bring a test charge test charge plus Q1, that's the plus Q1 test charge from infinite to point 1. From infinite to point 1. Point 1. Okay. So the external field, so work done by the external field, okay, that is W equal to Q times potential. Clear? That's easy. Now we discuss the another important concept like that, similar concept obviously, the potential energy of a system of two charge in an external field. Okay. Here the calculate potential energy of an external field. Now the potential energy of a system of two charge in an external field. One charge, I bring a two charge. Potential energy energy of a system of two charge of a system of two charge in an electric field. And electric field. Okay. So there is a external electric field. Okay. There is the external electric field. So that is the external electric field. Okay. So suppose we bring a charge Q. Suppose we bring a charge Q1. Q1 from infinite to that point 1. The position is, suppose that is a 0, that is R1. From bring infinite to that point 1, so there is a obviously a potential energy associated with this, that is U1. From being infinite to that, actually minus infinite from test charge Q1 or charge Q1 from infinite to that is need a work done. That work done, that is equal to Q1, the charge and potential at 1. Okay, function of R1. Okay, and we know that potential energy at infinite with a 0. Okay, so that is equal to U1. That is the external field. That is due to an external field. Okay. Now bring another charge. Suppose the charge is another charge is Q2, positive charge. Same condition, bring infinite to that point 2. That R2 is a position. Okay, from infinite to at point 2. So there is a work done. First, work done by the field U2 infinite to point 2. Okay, infinite to point 2. Change in energy, that is equal to work done. That is equal to Q2. Now Q2 behave as a test charge. That is the by the field. Okay, that is the energy, potential energy by the field times V2 potential at point 2, that is R2, and the infinite with a 0, that is equal to U2, that is by the field. Now you see the diagram very carefully. Okay, and you see that now Q1 charge here, before Q2 the Q1 charge present in that system, now Q1 also create an electric field. Okay, and also create a potential. So here we need a, here that is R12 distance. So when Q2 brings infinite to at point 2, there is a needed work done against that field, external field, or against that Q1 produced electric field against also. because Q1 and Q2 both are plus against that repulsive force, obviously. Okay, so work done U2. So there is another work done U2, that is Q2 times V2, that is not a function of R2, that function of R12, because that potential created by the external fields and that R12 or V2, that potential created by the Q1. So that is equal to Q2 and V2 of R2, you know that is Q1 by 4 pi epsilon naught of R1 to 2. Okay, that is 2 work done for due to U2 dash, suppose say that U2 dash total. So here the total potential energy of the system is, so U total, they obey the superposition principle, you know that for U1 and U2, U1 total and U2, and U1 we know that Q1 times V1 of R1, and U2 that is equal to Q2 V2 of R2, and here Q1 Q2 these Q by 4 pi epsilon naught of R12. That's the total U total. Box that. That's a very important expression, or say that equation, total potential energy. Okay, that's two. First is by the field, work done against the field actually, or here is the against that, another obviously the field, that a external field, these two are dependent on external field, and these two create a field in the system or PGS charge created by the field. Here is the field created by Q1, here V1 and V2 or V2 R1 are to created by the external field. These two are the external. Okay, clear the concept. So today end the class here. Next class we discuss potential energy of a dipole in an external field. When dipole plays an external field, what will happen? Next class we discuss. Okay. So thank you.